Our next pair of key functions come from the group of functions called rational functions. We'll have a lot more to say about rational functions when we are in our next chapter, but for now we just want to wave at a couple of them. The first one is called the reciprocal function. Looks like this. Let's see, I'm going to need some more of that. Some more of that. The equation is f of x is equal to 1 over x. So, the shape is this lovely thing with rotational symmetry. 1 over x, if x is 1, then y is 1 also, because 1 over 1 is 1. If x is negative 1, then y is also negative 1. If x is 2, then we have 2, and y is 1/2. On the other hand, if x is 1/2, we have y equal 2, and so on. Okay. We have in this function something that we haven't seen up to now. We have asymptotes. So we have both a horizontal asymptote. That means that y values get very close to a certain point, in this case y equals 0, but they never quite reach it, either on the left or on the right. They never reach it because the numerator here never is 0, so how can the whole thing be 0? Fact is, it can't. Then we also have vertical asymptotes. Well, I guess it's just one vertical asymptote. And the reason that we have the vertical asymptote is that we cannot have a 0 in the denominator. We can't have a 0 in the numerator because a 1's already there, and we can't transform that into a 0. And we can't have a 0 in the denominator because we never divide by 0. So that 0 in the denominator produces a vertical asymptote. Let's look at this in Desmos. There. And so we see it going through those dots at 1, 1 and negative 1, negative 1. Okay, and back to the drawing screen. Our second rational function, I don't know whether it has a name anywhere, but it is f of x is equal to 1 over x squared. And that looks a lot like 1 over x, but not quite, as you might expect. For one thing, it doesn't have odd symmetry. Instead, it has even symmetry. Still has the same asymptotes. Still goes through 1, 1, negative 1, positive 1. And by the way, the reason that these are called rational functions is that they are ratios of polynomials. And that's one of the things we'll have a lot to say about later on. Let's look at this in Desmos. So 1 over x squared. So you can see it has fundamentally the same shape as 1 over x, but again, x squared is a bigger number than x, so when we take the reciprocal, we get a smaller number. And notice again the even symmetry of the red graph here, which is 1 over x squared, and the odd symmetry of the black graph, which is 1 over x. let's see. What I forgot to mention up here is the domain and range. Domain is not all reals because I can't have a 0 in the denominator. So, to keep it short, I'll just say the domain is x is not equal to 0. So, that means x is allowed to be everything else. And the range, y, is not equal to 0. Now, these are not the same values that we have for the domain and range of the other rational function. Here, the domain is the same. X is not allowed to be equal to 0. But the range is strictly positive numbers. Y has to be greater than 0. So I could also write this way as positive reals. Like that. That's the end of this part.